Good morning. Today we're going to talk about 10.2b and its congruent arcs. So what makes an arc congruent? Well, two circles are congruent if and only if they have the same radius. So if your circles do not have the same radius, then they are not going to be congruent. And in addition to that, arcs are congruent if and only if they have the same measure and their arcs of the same circle or congruent circles. So what's important here is this word and. Both of those have to be true. They have to have the same measure, but they also have to be arcs that are within the same circle, or we know that the circles are congruent. So that meaning that the radiuses must be the same. Now, in addition to that, are central angles. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So same is going to go true for your chords, but notice here, because our central angles are the same, those are vertical angles, then we know that these chords, DE and CB, are going to be the same as well. And like you can see in this bottom diagram here, that will also hold true for chords. So let's apply this. We want to determine if the red arcs in each of these are congruent, and we need to explain why. So on the first one, C, D, and E, F, they both have an 80-degree central angle, and so because they're both 80 and they're within the same circle, then yes, they are congruent. So yes, they are congruent because they're in the same circle and the central angle is congruent. Okay, so then part B. If you look here, they both, we're looking at the red arcs there, they both do have the same central angle, but the problem is that the circles are not the same. So because the circles are not the same, then those arcs are not going to be congruent. So no, they're not congruent because the circles are not the same, meaning they don't have the same radius, which means they are not the same. Part C, if you look here, those are two different circles, but notice TV and XZ both have a single tick mark, which means they have the same radius. So even though they're different circles, they are congruent circles. And so they are congruent circles, and they both have a 95-degree central angle, meaning yes, they are congruent because they are the same size of circle and their central angle is the same. Okay, let's look at number 7 here. So number 7, again, there's two different circles, but notice that radius is the same. So because the radius is the same, we know the circles are the same, and then when we look, they both have a 145-degree angle. So yes, they are congruent because they are the same size of circle and their central angles are congruent. And number 8. If you look at number 8, they're now not giving us tick marks, but they're giving us side lengths. So that radius is 5 and this radius is 4. So even though they both have a 120-degree arc, they are not the same because they have to have both the same size of circle and the same central angle. So they're not the same because the circles are not same. They are not congruent. Okay, let's take a look at this one and let's apply some algebra here. So it's saying to find the value of x, and then we want to find the measure of that red arc. So remember that the angle degrees of a circle, a full circle, is 360 degrees. So we can say that 4x plus 6x plus 7x plus 7x has to give us 360. If we combine like terms here, that gives us 24x is equal to 360. When we divide by 24, we get x is 15. So that's the first part, find the x, but then it says, then find the measure of the red arc. Well, the red arc consists of 6x and 7x. So if I combine 6x and 7x, I get 13x, and 13 times 15 gives us, I don't have a calculator, so let's do this by hand. $195, so that means that is a 195-degree arc measure. And that is congruent.